given that 3 minus 2i is the root of 2z cubed minus 15z squared plus 44z minus 39 is equal to 0, find the other roots. Okay, so what would we expect? We've got a cubic, we've got one complex, so we would expect another complex root and one real root. Right, method 1. Since the coefficient of the cubic are real, and then as 3 minus 2i is a root, then obviously they pair in conjugate pairs, so z3 plus 2i is also a root. Then if we need to find a quadratic with these two roots, quadratics of the form a z squared plus bz plus c is equal to 0. The sum of the roots is alpha plus beta, which is minus b over a. So if we add these two roots together, we've got 3 minus 2i plus 3 plus 2i, that's equal to minus b over a. The minus 2i and the 2i's cancel out, and we get that 6 is equal to minus b over a. The product of these roots, alpha beta, is c over a. Then the product of these two roots is c over a. This is the difference of two squares, so this will be 3 squared minus 2i all squared, which gives you 4i squared. I squared is minus 1, therefore we'll get 9 plus 4, which is 13, will be c over a. Therefore c is 6 was minus b over a, 13 is c over a. If we let a equal to 1, then b is minus 6, don't forget to change the sign, and c is 13, and therefore our required quadratic is going to be 1z squared minus 6z plus 13 is equal to 0. Of course, we don't write the 1. Then finding the other factor in the original cubic, we can just divide into it. We've got 2z cubed divided by z gives z. Make sure you put these in the right columns when you do this. 2z times z squared gives you 2z squared. 2z times minus 6z gives you minus 12z squared. And then 2z times 13 gives you 26z. Then doing the subtraction, you get nothing from here. Minus 15 minus 12 is like minus 15 plus 12, which is minus 3z squared. And then 44 minus 26 gives you 18z. Bring down the minus 39, and then we divide this one. Minus 3z squared divided by z squared gives you 3. Minus 3 times z squared gives you minus 3z squared. Minus 3 times minus 6z gives you plus 18z. And minus 3 times 13 gives you minus 39. Then if we do the subtraction here, we get no remainder, which is what we expected, because we knew that this was a factor of the cubic. And therefore, the cubic is equal to the quadratic times this new factor here, and then from that we can say the other roots are 3 plus 2i, and from this one 3 over 2. However, there's a much easier way to do this problem. So let's just look at method 2. So we'll write out the original cubic. If z is equal, same idea, if z is minus 2i is a root, then obviously z is equal to 3 plus 2i. The coefficients do have to be real for that to happen, though. The sum of the roots of this cubic, is alpha plus beta plus gamma is equal to minus b over a. So we've got two of the roots, let's just add them together. And then just have the third root, which we've got to find, and say that's equal to minus b, so it's minus 15 over a, which is 2. Obviously the minus 2i's cancel out, so we're going to get 6 plus gamma is equal to 15 over 2, and therefore gamma will be 15 over 2 minus 6, which is 3 over 2. Therefore the other roots are going to be the 3 plus 2i, and z is equal to 3 over 2. Now either method's correct, but obviously this is a lot more efficient, much more easier way of doing the problem. Okay, so this has been a question about finding the roots of a cubic using the idea of the sum and product of the roots. I hope you've understood and I thank you very much for watching.